Okay, dokie. Let's get started with something that I really like because it has to deal with numbers, and I love playing around with numbers. So, since we're dealing with square roots here, square roots, what I really need to do is I really need to think of all the perfect squares, right? So, if you have a really hard time with perfect squares, please challenge yourself here. I'm asking you, please challenge yourself. Try to memorize the perfect squares. This conversation goes so much easier when you can. So I will start the notes and radicals in the form. There we are. I'm sorry. Radicals in the form of x. Now we read this here as the nth root of x. Now, the number here, n, is known as the index of the root. Probably way more information than you need right at this moment. But when we have the square root of 9, notice how there is no index. But what does that mean? What is implied? It means that the index is actually 2, right? And the square root of 9 means what two numbers multiplied together give you 9? 3, right? So, anyways, let me go. Radicals of the form the nth root of x, such as the square root of 90, the cubed root of 75, and the fifth root of 32 are what we call these entire radicals. Now, they're entire because all the numbers are in the radicand. There is no coefficient. Now, the radicand simply is the number underneath the radical sign. Radicals in the form a, so there's a coefficient in front of the radical now, a, the nth root of x, such as 4, this is one quantity, 4, the square root of 5, 3, the cube root of 27, and 2, the fourth root of 2, are called mixed radicals. We can simplify radicals using the multiplication property. The multiplication property states that the nth root of AB is equal to the nth root of A times the nth root of B. Now, I'm just thinking of two numbers in my head. So what we're saying here, for example, the square root of 36, for example, I need you to get your feet wet here, right? The square root of 36 can be written. Now, I know what you guys are saying. You're yelling at me that it's just simply 6. But I'm going to try to demonstrate the multiplication property to you. What it says is I could split up my radicand into two factors. Now, it really helps out if you can identify a factor that is a perfect square. And indeed, 36 is 6 or 9 times 4. And what we can do then is we can split that up into the square root of 9 times the square root of 4. That's what the multiplication property is. Now, I know what you're thinking. Well, it's just 6. Yes, the square root of 9 is 3. Square root of 4 is 2. 3 times 2, 6. So, to simplify a radical, we write the radicand as the product of two numbers. Any two numbers? No. Please try to spot out a factor that is a perfect square. So I want you to think right now, maybe you have a list of all perfect squares. What is a perfect square factor of 50? And it actually helps if you can pick out the largest one. And I believe there's only one perfect square factor of 50, 25. So to simplify the radical, we can write the radicand as a product of two numbers. 25 times 2. So we're going to write the radical first as 25 times the root of 25 times the root of 2. Now, I'm just going to finish this off. We all know we can evaluate the square root of 25, so this is better written as 5 times the root of 2. So then to check to see if you can take the square root of either of those numbers, so you can say that the square root of 50 is equal to the square root of 25 times 2, and then you can split it up as the square root of 25 times the square root of 2, and the square root of 25 is just 5 root 2, we call it. You can remove the square root sign because you have performed the operation. That's it. Now, I'm hoping to challenge you guys with trying to pick out the largest factor that is a perfect square. Some of this will be easy, some of this will be hard.